Hey, welcome back to the Mathtub with Mr. Elko. Today we're very briefly going to go over how to solve a complex trinomial, specifically when we have our standard form like this, but our a value does not equal 1, like some of the ones we've been doing in the past. So we're going to take a look at this example here, and what we're going to do is we're going to introduce the diamond method. So what the diamond method is basically we're going to take this, but we're going to use this symbol here. Actually, let's use a pen that's a little bit darker and easier to see. There we go. We're going to use that x there to split this trinomial into parts we can work with. The top part of the diamond is going to represent A times C. Our bottom part is going to represent our B. So this part here we multiply. So with the same factors that we did before, but we're going to actually be multiplying our A value and our C value together. But when we add them, they have to equal our B value. All right, so let's do our calculations here so we can get started. So we have 3 and negative 6, so when multiplied together, that gives us negative 18. But when we add together, our B value is negative 7. So this is where we have to bring up our factors, because this part of the diamond here is going to represent the two factors that we figure out. So we're going to go through, we're going to see what two numbers when multiplied together can give us this combination. So let's go 1, and because it's negative, we know at least one of them has to be negative. So negative 1, negative 18, and I'm just going to list as many factors as I can think of. Negative 2, let's go negative 6 and 3, negative 3 and 6. So let's see if any of these factors are able to help us out. Okay, so when multiplied together, all of those give us negative 18, but when we added, this one gives us 17. This one gives us negative 17. We have 7. We have negative 7. Oh, because I have my factor now, I don't need to go any further. So I know that this is negative 9, and this one is positive 2. So how we go from here, once we find our factors, this is where things get a little tricky. Basically, this middle term here, when we go back to our foiling, this is a combination of our like terms. Now, what these two factors represent are which two like terms we combine together. And because we know what they are, we're actually able to split this equation now into its like terms so we can combine the different parts together. So I'll show you what that looks like. Right? So we have 3x squared, and then I'm going to use my first like term of minus 9. Minus 9x. Now I'm going to use my second term of plus 2x minus 6. So all I've done is I've taken this negative 7x and I've split it into negative 9x and positive 2x, and I've kept my other two terms the same. Once I've done that, this is where we get into our factoring, where we can actually figure them out. I'm going to bracket off each of the two factors. This is where you could focus in on your greatest common factor piece. What can we pull out of each of these examples here? Now for this example, I can take out a 3, because 3 fits into 3 and 9. I can also take out an x that is present in each one. So as I factor it down, I'm going to end up with x minus 3. And now I'm going to do the same thing to this factor here. I can pull out a 2, and that's all I can pull out of this one. So I have a plus 2, x minus 3. So now I'm very, very close. As I can see here is I have 2 x minus 3's present in my example. So because I have 2 of them, I can factor that out, and that gives us our first factor. Then I have whatever's left over becomes my second factor. And there we go. We've solved it. And if we want to prove it, I'll put it up here so everyone can see. We just redo it. We're just going to use FOIL. X minus 3, 3x plus 2. First is 3x squared. Outside plus 2x minus 9x minus 6. And if we combine our like terms, 3x squared minus 7x minus 6. And we're done. Okay. So if you wanted to see how it works, that's what it would look like. And here's our process of how we go from a complex to our factored form. Well, thanks for joining me on the Mathtub. Look forward to another future video And then here, days